name is Shubham Sridhar Nadargi. I am working as assistant professor in Department of Mechanical Engineering at Walchand Institute of Technology, Solapur. Today we are going to discuss about scales. That is a part of engineering graphics, first chapter. In fundamentals, we are going to discuss about scales. That is more important for your drawing and as well as other part of your curriculum. So the learning outcomes of this entire short session is about, at the end of this session student will able to understand various types of scales and their use in engineering practice. Apart from this, student should able to understand what types of scales are available for specific applications and how these scales are useful for drawing, in to be more specific, engineering drawings. Today we are going to discuss about the scales, and the content of that entire session is representative fraction, types of scales, and at the end we are going to see one example based on representative fraction. Now in real world there are many objects which are at smaller or bigger in dimension. To draw a graphical views of that entire object, we need to have a graphical sheets. So we have limited sheet size in real life. That's why we either convert that entire object into smaller version, or if the object is very small, in case of imitation jewelry the objects are very small, and if we draw that object on that sheet, the detail will not be easily visible. That's why what we do in that case is we enlarge that imitation jewelry or any small object into bigger picture, so that the detailed view of that entire object can be obtained on the sheet. That's why what we do is we scale up the object, or we scale down the object on a sheet of paper. With the help of this we can see the details available in that object in 2D form. So based on this we are going to define one factor called as representative factor, and that representative factor is defined as ratio of linear dimension of an element of an object in that drawing to the actual linear dimension of same aspect of that object itself. And in the form of mathematical expression it is given by RF, means representative fraction equal to drawing length of an element to the actual length of that same element in that object only. This is about representative fraction. I hope this is very much clear to you and it is understandable one. After that we are going to discuss about types of scales. Students, we have many types of scales, but regarding engineering point of view we have scales, that is plane scale. After that we have vernier scale. After that we have diagonal scale. Since we are going to discuss about all these scales in detail, we are going to see the first scale, that is plane scale, in detail in next slide. Plane scale. Students, from childhood onwards we are using this scale, that is as from school practice we are using this scale, that is plane scale only. Okay, in that we are going to measure a linear dimension only, and the maximum length available in such scale is around 150 mm to 300 mm. That is usual one that we are using from childhood, that is 15 centimeter scale and 30 centimeter scale. And the length of scale is determined by, with the help of representative fraction. Length of scale is obtained with the help of one parameter called as maximum length to be measured This entire factor, that is maximum length to be measured, it will come from the object on which the dimension or drawings need to be prepared. In that object we are going to see the maximum side that is incorporated on the sheet, and that maximum length is taken here and multiplied with the representative fraction, and based on the product of that both, we will select the length of a scale. Okay, this is about plane scale. After that we are going to see the diagonal scale. Since the diagonal scales were popular in the diagonal scales were popular for measurement of maps, these scales were considered into account because they were considered up to 3-point fractions. That is nothing but, if we see meter, centimeter and millimeter, this is nothing but 3-point fraction. If you see, if any scale measures 2-point fraction, means it, let's for example I am considering, it will measure meter or centimeter, meter and centimeter. In that case it is 2-point fraction, and 3-point fraction means up to 3 units we are going to see measure the dimension, and these diagonal scales can measure 3-point fraction scale, and these are generally used to measure the distance on the maps, where in assistant town planners or any town planning engineer has a extensive use of these diagonal scales. The linear dimension with an accuracy of 0.1 mm can be measured using this diagonal scale. That's why it is most popularly used in engineering, more specifically civil engineering or remote sensing applications. Diagonal scales are used to represent 3 consecutive units, that is 3-point fraction only, that we have discussed earlier. After that, the most famous one and the scale that is used in first year of engineering, that is in physics, we have extensively used this scale called as vernier scale, and the vernier scale is used for small units, let's say 0.1, 0.2. In this way we can measure very accurately with the help of vernier caliper. Vernier caliper consists of vernier scale, or vernier, synonymously it is called as vernier caliper. It consists of one main scale. Main scale has a type of plane scale, and a vernier scale that is sliding on the main scale to show the accurate measurements. The least count of that vernier scale is nothing but 1 main scale MSD minus 1 VSD, where 1 MSD means it is main scale division and VSD means a vernier scale division. And one example we are going to see on the representative fraction is given here. The distance between two places is 240 km and its equivalent distance on the map is measured by 12 cm. The representative fraction for the scale for the above map is given by representative fraction equal to the formula that I have discussed initially, that is applicable here. And if you see, the numerator is nothing but the drawing dimension to the actual dimension. The scale is around 1 upon 20 lakhs. This is about scale of a particular of that map. Okay. Thank you, students.